Okay, so in this video, let's look at the proof of sine rule. So you should understand, we must prove them for the three triangles, such as the acute angle triangle, the right angle, and of course the obtuse angle. But you should understand, whenever in a question they say prove the sine rule for a triangle, four triangles, these are the two different concepts you should understand. If they are specifically mentioning that, it's okay to prove for only one triangle. But if they were saying prove the sine rule for triangles, then you should understand you must prove the sine rule for all the three triangles. So in this video, let's try to look at on how the sine rule is proved for an obtuse angle and for an acute angle. Of course, for right angle it is easy. So if you have an acute angle, of course the concept is the same. Okay, every time we used to consider certain height which is around here. So whenever you mark them, let's say the triangle is ABC. Opposite to A, we should have the simple A1, which means the length of BC. Opposite to B, we must have simple B. Opposite to C, we must have simple C. So that's the basic logic behind this. And we used to consider perpendicular height from A to the line BC. So let me just name it as X. So we should understand. So we are actually required to produce the sine rule proof. So let me just think about the sine. Because why? We know all the sides of this. You can see that if you consider this triangle, this is your hypotenuse. So when it comes to the sine part, of course it is opposite to our hypotenuse. So every time it is relatable with the sine. So if we just came across here, we can say that x over b, which is the opposite to our hypotenuse, will get you the angle along here, sine c. Similarly, if I write it for here, x over c will be equal to sine b. So we should be able to write it as, you can see both of the term has x. So we are finally able to arrange it as b over sine b is equal to c over sine c. As you can see that we have only proved this for sine b and sine c. So in here we are unable to obtain an idea about a. So we must obtain another perpendicular point from here to this line. So no need to show it again and again. So you can just write the step, okay? Since the perpendicular is drawn from A to the line BC, we are able to get this expression. So you can just say that similarly, when a perpendicular is drawn from point B to the line AC, we will be able to obtain it as C over sine C is equal to A over sine A. So finally we are able to equal all of these terms. So this is actually the proof of the sine rule for an acute angle triangle. So you should understand, of course, there's a case for the obtuse angle. So let me just come up with the next part.